In the previous video, we explained how 2-degree of freedom PID control provides excellent temperature control in both set point and disturbance response. This video introduces the steps for PID control with OMRON'S E5CC controller, from wiring to tuning parameters. Let's look at controlling an electric furnace to reach 300 degrees Celsius. First, prepare the necessary components: sensor, heater, controller, output device, and power supply. We'll use the commonly used K-type thermocouple and solid-state relay. Let's start wiring. For the temperature controller wiring, you need to check the terminal block in the datasheet and manual. The E5CC has 5 terminal groups: sensor input, control outputs, auxiliary outputs, input power supply, and options. Connect the input power supply to terminals 11 and 12 to operate the E5CC. Now connect the sensor. The terminal numbers for sensor input vary depending on the type. For the thermocouple input, use terminals 5 and 6. Next, connect the SSR to the E5CC. E5CC sends a voltage signal to control the SSR, which turns the heater on/off. Therefore, connect the E5CC control output terminals to the SSR input terminals. The terminal numbers for control output vary depending on the type. For the voltage output, use terminals 1 and 2. Next, connect the SSR to the heater. The heater turns on when powered, and the SSR controls power supply to the heater. Connect one side of the AC power supply to the heater through the SSR, and the other directly to the heater. Wiring is complete. Let's move on to the controller settings. First, turn on the AC power to start E5CC. Set the input type based on the sensor used. Refer to the manual for the sensor type and desired temperature range. This time, we'll use thermocouple. The input type defaults to K-type thermocouple. We will use K-type again with a maximum temperature range of 400 ohms in 0.12 increments, so we select 6. Let's set it up. Press the level key for 3 seconds to display the input type parameter. Use the up key to change from 5 to 6. Next, set the control method. Press the level key several times to display the control method parameter. Change from on/off to 2-degree of freedom PID. Set the target temperature. Hold the level key for 1 second to return to the operation screen displaying current and target temperatures. Press the shift key to select the digit to change and up keys to set 300 degrees Celsius. Once the target temperature is set, control begins. P, I, and D parameters have default values. Now let's look at the temperature control waveform. The initial PID values do not match the characteristics of the control target, causing hunting. Therefore, the P, I, and D parameters must be adjusted to suit the control characteristics. Let's see how to manually adjust the P, I, and D parameters. To suppress hunting, let's increase the P value. Hunting still hasn't stopped, so we'll increase the P value further. Hunting stops, but the heating time becomes much longer. To shorten the heating time, let's reduce the I and D values. The heating time is still long, so we'll reduce them further. Now the time is shortened. To shorten more, let's reduce P value. But hunting has reappeared again. As you can see, adjusting the optimal PID values manually is difficult and time-consuming. The temperature controller has an auto-tuning function that adjusts PID parameters in one step, eliminating the need for trial and error. Let's use the auto-tuning function. Press the level key for 1 second on the operation screen. Press the mode key to display the AT execute cancel parameter. Select 100% AT execute and start it. The tune light turns on when auto-tuning begins. It calculates PID values based on hunting cycles and amplitude using on-off control at the target temperature. Tune turns off when finished. Let's review the control waveform. We achieved fast, stable temperature control without overshoot or hunting. Using auto-tuning, you can find the optimal PID parameters in one go, achieving precise control. This video introduced how to perform PID control with our E5CC temperature controller. Click here for the details about our E5CC controller. In the next video, we will introduce input-output device types and additional functions of temperature controllers.